Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about problems on the total hardness in terms of calcium carbonate equivalent by using EDTA method. So here, a water sample of 100 ml, it's required 8.4 ml of 0.02 m EDTA with EBT as indicator. So already previous classes we discussed what is the procedure of EDTA and how can we determine the hardness, how can we estimate hardness by using EDTA method. So briefly we discussed just now. What is that in EDTA method? Mainly used for EDTA to estimation of hardness by using this EDTA. So EDTA abbreviation is ethylene diamine tetraestic acid. So in this case generally in hot water it containing hardness causing ions. Different types of hardness causing ions present in different amounts in water. So for example calcium or magnesium ions of bicarbonates, chlorides, sulfates etc. present in water in different amount in that water. So how much amount of hardness present in that water, it can be estimated by using EDTA, ethylene diamine tetraestic acid, because this EDTA acts as a complexing agent. That means it forms complex with hardness causing ions which are present in water. So this purpose we are using aerochrome black tea indicator. So this EBT indicator, when we are adding in this water, the color of the solution is wine red. So previous slide we shown that wine red. When we are adding EBT indicator, the color of the solution is wine red. So after titration with the EDTA, the color of the solution is blue. So that is the end point. So end point determination purpose we are using EBT indicator, aerochrome black tea indicator, and also we are using here buffer solution. So generally here we are using buffer to maintain the stable pH. So that a stable pH range is here in this EDTA method 8 to 10. So that purpose we are using ammonium chloride and ammonium hydroxide buffer we are using in this EDTA method for determination of hardness. So here, so this is a procedure based on by using EDTA method. So previous classes already discussed clearly how can we estimate hardness of water by using EDTA method. So today's class we discussed about numericals based on that EDTA. So here in this problem a water sample of 100 ml required. So volume of water sample is 100 ml. So volume of water sample is 100 ml. It required EDTA is 8.4 ml. 8.4 ml. And the molarity of EDTA is 0.02 m. The molarity of EDTA is 0.02 m EDTA. And here we are using indicator is aerochrome black tea indicator we are using in this EDTA method. So after removing the carbonate hardness, that means we can remove temporary hardness causing ions such as for example calcium, magnesium bicarbonates. So here 100 ml of water sample required 8.4 ml of EDTA and the molarity of EDTA is 0.02 m. So in this case, we are using indicator is aerochrome black tea indicator. So this is the data which is used for removing the carbonate hardness. We can remove temporary hardness causing ions by boiling. So now calculate the permanent hardness in terms of calcium carbonate equivalent. So we can calculate here permanent hardness according to data, and after that we can convert it into calcium carbonate equivalent because it makes calculation is very easy when we converting in this calcium carbonate equivalent. So how can we solve this? How can we calculate the permanent hardness of a given water sample? So your solution is given that 8.4 ml of 0.02 m EDTA. 8.4 ml of 0.02 m EDTA are required. 100 ml of water. 100 ml water sample required. EDTA is 8.4 ml and the molarity of the EDTA is 0.02 m. So after removing temporary hardness, after removal of temporary hardness, this data. So here formula we are using here is M1V1 equal M2V2. So here M1V1 related to EDTA and the M2V2 related to water. So here M1 means molarity of M1 is molarity of EDTA. So molarity of EDTA already given here. So what is that from the data? Molarity of EDTA is 0.02 m. And next V1 is the molarity volume of EDTA. So volume of EDTA is here it is given 8.4 ml. So it's equal 8.4 ml. So what is the formula we are using for this purpose? M1V1 equal M2V2. So in this case M1V1 related to EDTA, M2V2 related to water. So here M1 means molarity of EDTA. So already given in that problem molarity of EDTA is 0.02 and V1 is the volume of EDTA. So its required water sample required EDTA is 8.4 ml according to data. And next M2 is the molarity of water. So molarity of water we don't know that. So this values we can find out. M2 equal, we have to find out molarity of water sample, given water sample. So we have to find out, so put the question mark. And next V2 is the volume of water sample. Volume of water sample. So how much ml volume of water sample? It's equal 100 ml. So now we can calculate the M2 value. So what is the formula? M2 equal M1V1 by V2. So we can substitute it all the values which are related to this. We can substitute it in this formula. So M1V1 by V2. Here M1 is the molarity of EDTA is 0.02 and V1 is the molarity of volume of EDTA is 8.4 and V2 is the volume of water sample. It's equal 100 ml. So after calculation, we'll get the molarity of water sample is 0.00168 m. 0.00168 m. So permanent hardness in terms of calcium carbonate. So how can we calculate the permanent hardness of water? So its formula is permanent hardness. It's equal M2 into 100 into 1000. It's equal dash ppm. So here M2 means molarity of given water sample. Just now we calculated what is that value? 0.00168. So we can substitute in this formula M2 into 100 into 1000. So M2 value is 0.00168 m and into 100. 100 is the molecular weight of calcium carbonate. 100 is molecular weight of calcium carbonate. And into 1000. 1000 is the total makeup solution is 1000 ml. So 0.00168 into 100 into 1000. It's equal 168 ppm. It's equal 168 ppm. So in this way you can calculate the permanent hardness of given water sample by using EDTA method. So next one is 50 ml of boiled water when titrated against EDTA consume 9 ml of the solution. 50 ml of boiled water when titrated against EDTA consume 9 ml of the solution. So here find out the temporary hardness and express 8 ppm of calcium carbonate equivalence. So if the total hardness is 600 milligrams per liter and molarity of EDTA is 0.001 m. So what is the solution here? So given the total hardness of given water sample is 600 milligram per liter. Here is given that total hardness of given water sample is 600 milligram per liter. So here formula is M1V1 equal M2V2. So M1V1 related to boiled water. So we can remove already temporary hardness in this, that means permanent hardness of water. So total hardness of given water sample is 600 milligram per liter, and here M1V1 related to boiled water sample and M2V2 related to EDTA. So boiled water sample means we can, after boiling, we can remove temporary hardness causing salts which are present in water. So M2V2 related to EDTA. So here M1 means molarity of boiled water. M1 means molarity of boiled water. So what is that? 0.001. So we can substitute here. M1 value is 0.001 given in the data, and into V1, volume of boiled water, its value is 50 ml. Volume of boiled water is 50 ml by V2. V2 means volume of EDTA. So here volume of EDTA is 9 ml. So we can substitute in this formula. So we can calculate the M2 value. So M2 means molarity of EDTA. Molarity of EDTA. So here M2 equal M1 V1 by V2. So it's equal 0.001 into 50 by 9. It's equal, after calculation we'll get 0.0055 M. 0.005 M. So molarity into molecular weights is equal. Already we know that weight in grams per liter. So molarity of that water, that EDTA is 0.005 M. Sorry, here this is a molarity. We can calculate here molarity of water sample. So that is the value is 0.0055 M, and molecular weight of calcium carbonate is 100. So it's equal 0.55 gram per liter. So permanent hardness equal 0.55 into 1000 total makeup solution. So it's equal 550 milligram per liter. So how can you calculate the temporary hardness of given water? So temporary hardness equal total hardness minus permanent hardness. Total hardness of given water sample is 600. So we can substitute here, and permanent hardness is 550. So it's equal 50 milligram per liter. So in an estimation of hardness of water by EDTA titration. So here 250 ml of a sample of water required 15 ml of 0.025 m EDTA solution. So to get the end point and calculate the hardness of water. So here we know that 1 ml of 1 m EDTA is equal 100 milligrams of calcium carbonate. So 1 ml of 0.01 m EDTA equal 1 milligram of calcium carbonate required. So therefore 1 ml of 0.025 m EDTA is equal how many milligrams of calcium carbonate equivalent? It's equal 2.5 milligrams of calcium carbonate equivalent. So now you can calculate the total hardness of given water sample. So volume of water sample is 250 ml. 250 ml. So 250 ml of sample of water required. It's equal 15 ml of 0.025 m EDTA. 0.025 m EDTA. So it's equal 15 into 2.5 milligrams. So it's equal 37.5 milligrams of calcium carbonate equivalent. So 250 ml of sample of water required 37.5 milligrams of calcium carbonate equivalent. So therefore 1000 ml of sample of water required 37.5 into 1000 by total volume of water sample is 250. So 37.5 into 1000 by 250 is equal 150 milligrams of calcium carbonate. So total hardness equal 150 ppm or 150 milligram per liter. Next one is sample of water of 100 ml required 12.6 ml of 0.02 m EDTA solution with EBT as indicator. So your water sample volume is, given water sample volume is 100 ml and it's required 12.6 ml of EDTA. It's required 12.6 ml of EDTA and the molarity of EDTA is 0.02 m EDTA solution. And already we know that in this procedure of EDTA method, which indicator we are using here? Aerochrome black tea, EBT indicator. And next case, 8.4 ml of 0.02 m EDTA for the same volume of water after removing the carbonate hardness. So what is the meaning here in the second case? Same volume of water, that means 100 ml of water, but it's required 8.4 ml of EDTA and molarity of the EDTA is 0.02. But here we can remove the temporary hardness causing ions which are present in water. For example, calcium, magnesium, bicarbonate present in that water. So we can remove the temporary hardness by boiling. So in that case, it's required that boiling water, after completing boiling, filtered and cooled, that remaining sample water is make up 100 ml by using distilled water. So that 100 ml water sample after removing temporary hardness, it's required 8.4 ml of EDTA and the molarity of EDTA is 0.02 m. So here calculate the total permanent hardness in terms of calcium carbonate equivalent. In terms of calcium carbonate equivalent. So how can we calculate the total hardness and permanent hardness and temporary hardness of given water and in terms of calcium carbonate equivalent? So here 100 ml of water sample required according to from the data. 100 ml of water sample required 12.6 ml of 0.02 m EDTA solution. 12.6 ml of EDTA required and the molarity of the EDTA solution is 0.02 m. This is the data used for determination of total hardness present in given water sample. Next one is 8.4 ml of 0.02 m EDTA solution required for the same volume, that means 100 ml of water sample. Required this EDTA volume is 8.4 and the molarity of EDTA is 0.02 m. So in this case we can removing the temporary hardness causing salts. So this data is used for determination of permanent hardness of given water sample. So now we can calculate the molarity of hard water, given hard water. So here we are using formula is M3V3 equal M2V2. So M3V3 related to hard water and M2V2 related to EDTA. So here M3 is the molarity of hard water. So we don't know that value. So we have to find out. So put the question mark. And next V3 is the volume of hard water. Volume of hard water. So how much ml hard water required here? So 100 ml. So V3 equal 100 ml. And next M2. M2 is the molarity of EDTA. So already it's given in the data. So it's equal 0.02 m. It's equal 0.02 m. And next V2 is the volume of EDTA consumed. Volume of EDTA consumed. So in the first case, how much ml volume of EDTA consumed? 12.6. So it's equal 12.6 ml. So now you can calculate the M3 value, molarity of given water sample. So what is the formula? M3 equal M2V2 by V3. M3 equal M2V2 by V3. So in this formula, we can substitute all the values in this formula. So M3 equal M2 means molarity of EDTA is 0.02 into V2 value, volume of EDTA required is 12.6 by volume of hot water V3. It's equal 100. So 0.02 into 12.6 by 100 is equal 0.00252 m. So molarity of given water sample is 0.00252 m. So by using this one, molarity of given water sample, we have to calculate the total hardness of water. So total hardness equal, what is the formula? M3 into 100 into 1000. So M3 value is 0.0025 into 100. 100 is the molecular weight of calcium carbonate. And next 1000 is the total makeup solution. So 0.0025 into 100 into 1000. So after calculation we'll get 252 ppm. So total hardness of given water sample is 252 parts per million or 252 ppm. Now you can calculate the permanent hardness of water. So from the data, 8.4 ml of EDTA required for 100 ml of water sample and the molarity of EDTA is 0.02 m. So 8.4 ml of 0.02 m EDTA for the same volume of water after removing the carbonate hardness. By boiling, we can remove temporary hardness causing salts. Already we know that the procedure. How can we remove the temporary hardness causing salts? So after that 100 ml water sample required after removing temporary hardness causing salts, the EDTA volume is 8.4 and the molarity of EDTA is 0.02 m EDTA. So here we are using formula is M4V4 equal M2V2. So M2V2 related to EDTA and M4V4 related to hard water. So hard water versus EDTA. So here M4 is the molarity of hard water. We have to find out. So put the question mark. And M2 is the molarity of EDTA. So already given in the data. So its value is 0.02 m. Molarity of EDTA is 0.02 m. And next V4 is the volume of hard water. So it's equal 100 ml. Volume of hard water is 100 ml. And next V2 equals volume of EDTA consumed. Here is given 8.4. So V2 equal 8.4 ml EDTA required for this. So we can substitute all the values in this formula. So what is the formula we are using here? M4 equal M2V2 by V4. M2V2 by V4. So M4 equal 0.02 into 8.4 by 100. So it's equal 0.00168. So the molarity of permanent hard water is equal 0.00168 m. So now I can calculate the permanent hardness of water. So what is the formula? Permanent hardness equal permanent hardness. It's equal M4 into 100 into 1000. It's equal dash ppm. So this is a formula used for the determination of permanent hardness. So here M4 molarity of given water is, just to be calculated here, 0.00168. So we can substitute in this formula. So 0.00168 into 100 into 1000. So already we know that 100 is the molecular weight of calcium carbonate and 1000 is the total makeup solution is 1 liter. So M4 into 100 into 1000. So 0.00168 into 100 into 1000 is equal 168 ppm. So permanent hardness of given water sample is 168 ppm. So next, temporary hardness. How can we calculate the temporary hardness of water sample? So temporary hardness equal total hardness minus permanent hardness. So total hardness of given water sample is 252 minus permanent hardness of given water sample is 168. So total hardness minus permanent hardness means 252 minus 168. So it's equal 84 ppm. So temporary hardness of given water sample is 84 ppm. So here total hardness of given water sample is 252 ppm and permanent hardness of given water sample is 168 and temporary hardness of given water sample is 84 ppm. So in this way we can calculate the total temporary and permanent hardness of given water sample by using EDTA. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.